The U.S. and the European Union, along with more than 100 countries, have made a pledge to collectively reduce methane emissions by 30% by the year 2030. While fossil fuels are responsible for the majority of those emissions, the livestock industry also faces a tall task. And researchers here want to make sure what may be right for the environment is also right for cattle. Headline after headline, methane emissions from cows are a growing point of contention.
90+% of the methane that come from ruminants is all going to be eructated. And so that's going to come out in a belch. And so that's where it's all coming out the front end.
Those emissions come from fermentation.
All the fermentation's on the front end.
Which is actually an important part of how cattle digest what they're eating.
Methane is really an important end product of rumen fermentation. It actually removes hydrogen ions, and so that helps fermentation continue. So while it's good for the bacteria, it's not necessarily great from the animal standpoint because it's just a loss of energy. And so with that, we're trying to reduce that while still proceeding with ruminal fermentation and helping the animals continue to grow.
Josh McCann, an assistant professor here in the Animal Science Department at the University of Illinois, along with U of I's Dr. Rod Mackey, are leading the charge to reduce methane emissions from ruminants like beef and dairy cattle.
What we're working on is we're trying to make sure the hydrogen that can kind of accumulate when we're reducing methane, that we can capture that hydrogen for productive purposes and to help animals grow faster and be more productive.
Through a 3-year, $3.2 million project, University of Illinois researchers, along with an international team, are trying to uncover answers to not only help reduce the emissions, but also help boost production in cattle.
We have a lot of feed additives that are getting developed now that are being developed to reduce methane. The problem with those is they don't really have any animal benefits.
By optimizing the fermentation that happens within a cattle's stomach, the researchers want to find out if an improvement in fermentation can also help animals grow faster and be more productive.
We can model that here in the lab with our kind of glass fermenters that we call. So essentially, they function like the stomach or a miniature stomach that cattle have, where they do all the same normal processes of fermentation. So we have the microorganisms, and they'll digest the feed particles just like they would in the stomach of a steer.
McCann says there are several approaches the researchers are taking to improve the fermentation process.
In essence, we're trying to understand how can we orient, the different bacteria here within the rumen to capture that hydrogen. So that hydrogen gets captured into volatile fatty acids. Those volatile fatty acids are then the primary energy source for the ruminant animal.
With the first phase of the grant focusing on understanding the fermentation pathways happening inside the rumen, to the next phase of moving into more experiments, researchers hope what they uncover here will ultimately fuel improvements around the globe.
We want to bridge the gap of knowledge where we kind of now understand how we can reduce methane, but we want to unlock that gap that's going to allow that to translate to a benefit on the farm for producers and in animal performance, so we can continue to raise livestock in a sustainable and effective way as a great source of food.
Well, what's the possibility of turning pig waste or manure into pavement? It's not only possible, it could be just a start. We'll tell you why next.